Erik Schultes, since 2018, has been the lead of the FAIR implementation at the Go FAIR Foundation and is currently senior researcher leading FAIRification efforts. There's a new word, mark it down, at the Metabolomics and Analytics Center and the Leiden Academic Center for Drug Research. Recently, Erik has helped launch the Leiden Institute of Fair and Equitable Science as part of the scientific and translational management team. He's co-author of the original publication of the FAIR Guiding Principles, co-developer of the first FAIR Maturity Evaluation Service, and architect of the now widely adopted FAIR Implementation Profile for driving FAIR convergence. Dr. FAIR indeed. Along with Barbara Magnania, Erik created the 3-point FAIRification framework, which has led to the development of the first accredited and qualified FAIR awareness training programs for executives and frontline data producers. He's currently the co-chair of the FIP and Practice Working Group of the FAIR Digital Object Forum. He's an evolutionary biologist by original training with a data-intensive research focus and has held several previous academic appointments at UCLA, the Whitehead Institute for Biomedical Research, the Massachusetts Institute of Technology, and the Santa Fe Institute. Erik, we're just so pleased to have you here with us, and I will turn the virtual podium over to you. And Erik is here live.
Hey, thanks a lot, Chuck. You know, that biography was meant to be edited down, so you know, I didn't think it would be.
Everything was important.
Yeah. Okay. Good. Well, it's also, you know, a real honor to be asked to kind of be the trail end on your workshop today. And I'm sorry I couldn't be here earlier. I'm coming to you live from Berlin at the moment, where we are in the middle of a workshop here that I think is quite relevant, amazingly overlapping with your own efforts in MCBK. We're working on the European Open Science Cloud. And the idea behind this is to have a European-wide infrastructure that could provision, for example, biomedical knowledge and knowledge graphs. So I see all kinds of very interesting connections, but let me switch over. I'll see if I can grab the screen here. And so I assume you can see that. And I will go into play mode. Sometimes Keynote gets a little bit hung up on Zoom, but let's see if this is going to work fine. And I cleared this title with Chuck. So it's you know, I think this is a keynote. Usually the keynotes are much you know, are high level and kind of metaphorical and meant to give broad context. I am doing that in part in this presentation, but I think for most keynotes, we'll go a little bit more into technical things than you might in an ordinary keynote, and I hope that's okay. And indeed, my background is at the moment the Go FAIR Foundation and the Leiden Academic Center for Drug Research, so Leiden University, and then this new institute that's emerged called the Leiden Institute for Fair and Equitable Science. And I saw the word equitable in Susan's talk, so I think that's also a time has come for that word to surface. First, I wanted to mention, I added this slide sort of at the last minute. You know, I think what MCBK is trying to do is incredibly ambitious. The vision was there, I think, at least since 2018. And I think in the same, as we could say for this general business around FAIR and data verification, some of this seems sometimes impossible. These are huge ambitions. And if we can imagine sort of turning, you know, the entire internet into one giant searchable, understandable database, a lot has to happen for that. And again, just catching the tail end of Susan's talk, you know, she's capturing some of the complexity in terms of standards and training and knowledge and technology. Yet at the same time, it seems like this is inevitable. the interoperability of information has been on a continuous trend over the last 70 or whatever years of computer science. We've always been moving towards more interoperability, and the payoffs of having interoperable data are so huge that it really sometimes also seems like it's going to happen regardless. And that's actually getting part of the punchline of the presentation today is, I think we're close. I think we're extremely close to, or at least we could say we have the technology available. If we can come to certain agreements, and if we're willing to assemble configurations that work, I think we could realize these dreams in short order. It's a bit of a complicated presentation, but these are the 6 components. So I'll give a very quick introduction to my background because it covers some of the things I think that's interesting to MCBK community. But it's also, let me get rid of this. Yeah, sorry, I'm trying to get rid of some clutter here on my screen from Zoom. Yeah, so yeah, here we go. Okay, that didn't work. Sorry. I will go back to sharing my slides. Yeah, here we go. So I will give a quick introduction to my background. There's a moment where I want to say, in other words, what this vision is, and I'll frame it in terms of what people have called fair digital objects. Then I want to talk a little bit about the technology. That's where things will get technical. We'll talk about an existing technology called nanopublications, which is what Chuck and I had been talking about earlier, and maybe led to this presentation now. I'll show an application of nanopublications as fair metadata, and then I'll make this a link between nanopublications and FDOs, so a link between the vision and the technology, and then relate that to computable biomedical knowledge. And what I will advocate here is not a particular technology. It's not like I'm trying to convince you that nanopublications are the way to go, but it's just to say I think we have technologies available to us today that can satisfy some of the needs and requirements that I see in the MCBK manifesto. Okay, so my background, I can say I've published a few papers on knowledge engineering and text mining and trying to do biomedical discovery on knowledge graphs. And when we were doing this work, when I was doing this work about 10 years ago, the vision was very much in line with MCBK that, it should be that insights that are valuable for a researcher or even for a physician or a patient, that those insights should somehow be readily findable and retrievable and made available to anyone at any time. And, so there was a lot of experiments we did. We had very interesting results. And it was this work with text mining that actually led to some of the first workshops on FAIR. We ran a workshop with the Lorenz Center, a very interesting organization based in Leiden, in 2014. And that workshop, many of the participants were working together over the next 10 years together. And a lot of activity has happened. We commemorated the 10-year anniversary of that workshop in January of this year with a follow-up Lorenz conference, sort of looking back over the last 10 years and then looking forward. And again, the word equitable made it into the new title. And I'm just trying to show here, there's a lot of activity in that last 10 years. There's, I think, 15,000 citations on the original FAIR Principles paper. And we see all kinds of technology, training programs, methods. I'm highlighting the CDAR workbench here that you might have heard about earlier today. This is a key instrument in our metadata for machines workshops. So it's to say a very rich and very busy 10 years, a lot of interesting developments. If we go back to 2016, the the paper that announced the modern form of the FAIR principles tells us, in fact, that the FAIR principles were meant to enhance the ability of machines to automatically do FAINR, that there should be a lot of capability of machines to assist and support human researchers in their activities. And again, just catching a little bit of Susan's talk in the role of LLMs, we think that FAIR is exactly what LLMs have been waiting for, or what they need to really produce high quality, trustworthy results. This is the FAIR principles as they appeared in that paper. It was a simple figure item, box 2. And in addition to the overall FAINR, there's actually 15 one-liners here that are really technical. They're getting at either infrastructure or let's say domain-specific aspects of data that need to be accounted for if it is possible for the machine to then do FAINR autonomously. After working with the FAIR principles for the last 10 years, I feel pretty comfortable kind of reducing it down to these 3 main aspects. So the FAIR principles are first and foremost meant to make information machine actionable. And I love this word computability, which I'm stealing from the MCBK community. FAIR data is supposed to be using knowledge representation systems, languages, and controlled vocabularies that can essentially reduce or eliminate the ambiguity that we have as in a normal human language. If we can reduce that ambiguity to 0, then it becomes essentially computer code, and the machine can help us. The trustworthiness of FAIR comes from the fact that the FAIR principles are asking for rich provenance metadata, which will help us to then interpret any potential biases or uncertainties, error corrections, etc. So that we think the rich metadata of FAIR data helps us to evaluate the trustworthiness and the reusability of the data for a particular purpose. And then the FAIR principles are also asking that data have explicit reuse conditions, and that we think the equitability can be technically ensured, even in the way that blockchain, for example, can ensure transactions in a trustworthy manner. Okay, so that's a little bit about FAIR and a little bit about my background. There's a vision of an internet of FAIR data and services that you can trace back to at least 1995. And I'm showing a paper here published by Bob Kahn, who happens also to be the inventor of TCP/IP, the core technology that runs the internet. So as if running an internet wasn't enough, Bob also had this vision that there would be a day when infrastructures based on open architectures would be able to support a large and extensible class of distributed information services. And these services would run on something called digital objects. So basically any kind of digital content or code that could be adequately addressed in a meaningful way. And the idea is really, we want to define basic entities to be found in such a system in which information in the form of digital objects is stored, accessed, disseminated, managed. I recently reread this paper, and it's really, anticipating FAIR 30 years ago. There's been a lot of work on what FAIR digital objects might look like and how they might operate. I'm just drawing, or I'm supplying here a schema from the FAIR Digital Object Forum, which is a very active group right now investigating how to implement at a broad scale FAIR digital objects. In 2019, Peter Wittenberg and I tried to relate the digital object architecture to this new idea of FAIR, and now there's this idea of what people call FAIR digital objects. So that was a vision. Meanwhile, by 2009, there was another interesting idea, but it was completely independent of digital objects or fair digital objects. And I know that because I was working with Baron Mons at the time, and he and Jan Velterup wrote this little paper about nanopublication in the e-science era. And the idea here was that individual knowledge units could be encapsulated and published in and of themselves. And so typically in a research article, we have lots of assertions we want to make. Some of them may be worthy of republication as a standalone entity, referencing an article, for example, but themselves being independent. And so I'm kind of highlighting some of the main aspects from the paper, but I can also just say where this thinking led to was, okay, we could have knowledge. Let's call it, these elementary knowledge units or assertions, and they would be associated with some kind of provenance, some kind of metadata. So who said this? When did they say it? And then some publication info. So this information, the assertion and the provenance, is republished as a nanopub and is a standalone entity. So for example, malaria is transmitted by mosquitoes. It's a simple subject, predicate, object combination, a simple sentence, a unit of thought of biomedical relevance. It could be true, it could be false, but it is an assertion. And maybe that assertion is made by a person at a particular time. And then maybe someone else comes by and repackages it as a nanopublication. And all of this information can be given a unique, globally unique, persistent, resolvable identifier, and it can become a referenceable standalone publication. And if it's made machine actionable, could be made available for participation in knowledge graphs. So it's really a single idea that you want to publish. It's atomic, it's unitary, it's a semantic unit. And nowadays, this is what a modern nanopublication would look like. You're looking at RDF here, a research description framework, resource description framework. There's a header section. The assertion is in blue. The provenance is in red, and the publication info is in yellow. And if you look closely, you'll find date and timestamps. You'll find a public key so that this is authenticated. There's an ORCID that represents the author, and there's an assertion here written in RDF. In 2015, we ran, we were part of a project with the Phantom 5 Consortium that was then, at that point, mapping transcriptional start sites in mammalian genomes. It was a huge data set. We republished some of that data using nanopublications, and we had to use 3 nanopublications to represent a transcriptional start site in this case. And this was, at this point, an academic exercise because it was a proposed standard, but no one was using this except us. So this was kind of a proof of principle. We took these nanopublications. In the end, we zipped it up put in a big file, and it's never been seen again. It's posted somewhere online. But by 2016 and 2021, Michel Dumontier and Tobias Kuhn started work on what they now call the nanopublication server network. And because the nanopublication is such a standardized format and it's machine actionable, they could formulate a system by which services could be designed to do things with nanopublications. And so on the nanopub monitor right now, you can see that there's 30-something nanopublication services that are available. The nanopublication server network is at any one time hosting, I think, 20 or 30 nanopublication servers. There's millions of nanopublications now that have been published to those servers, and it's radically open, radically decentralized, and available to anybody. Some of the services that run on the nanopublication server network include this provision of date and timestamps, these authentication keys, and what we call trusty URIs. The content of the nanopub gets cryptographically hashed And then that long alphanumeric hash code becomes part of the URL for the nanopub. If anything should change in the nanopub, that would then trigger a new URI for the nanopublication. So it's very difficult to forge or to corrupt a nanopublication once it's been published. But there's also services for authoring nanopublications, for providing licenses on nanopublications. You can build search and dashboard tools, and you can build nanopublication templates that are a little bit, I would say, like a CDAR form. They become templates that are reusable by others. So coming back to the nanopublication, we can see that there's a globally unique persistent identifier at the top, in the top red arrow, publication key, date and timestamps. And then in a service called NanoDash, you can search for nanopublications, you can publish them, and you can reuse templates that are listed here. So that technology is actually quite mature and has been doing lots of interesting things. Here's an application. In GoFair, we needed to help different organizations try to fairify their own resources. And that can be quite complicated. There's a lot of FAIR principles, and there's a lot of resources that people can use. So we designed this idea of a FAIR implementation profile, and it's really quite simple. It's just a list of technology choices, call it FAIR enabling resources, that satisfy each of the FAIR principles. And so if you manage to actually verify your data, it's very easy for you to actually reproduce your FAIR implementation profile. And we tie that to a particular community of practice. So now different communities can share their approaches to FAIR, including, by the way, the use of their vocabularies and schema, etc. We started this exercise with spreadsheets and free text, but we designed a ontology, and we were able to define up to 12 different types of FAIR enabling resources for each of the FAIR principles. And we could then use this ontology, and we could embed nanopublications into this process by which you can make your FIP. And so now we can have FAIR implementation profiles expressed as a collection of nanopublications. And so we have a nanopub for the community, and we have a nanopub for each and every FAIR enabling resource and the different types. And then there's another nanopublication that makes the link between the community and the resource. And so a collection of resources becomes the FIP. So we have a single nanopublication that points to this list of FAIR enabling resources. And we have then represented the FIP in a completely machine actionable way as a collection of nanopubs. And we can search and do things with those nanopublications at an interface called FAIR Connect. So you can do search, and you can have dashboard to see which communities are publishing FIPs and what FAIR enabling resources are available. And so that was an application along with FAIR Connect. It's been very successful, and we see a lot of uptake on that. In hindsight, and we certainly didn't set out to do this, but in hindsight, we realized that the nanopublication assertions that we made for the purpose of the FIP actually looked a lot like a FAIR digital object. So we have, in the assertion, we point to the FAIR enabling resource, this resource on the web. We describe it with a type coming from an ontology, and we provide a little bit of metadata about that. And we realized, again, only in hindsight, was that this was mapping in a very straightforward manner onto these early ideas on FAIR digital objects. So we described that, this interesting coincidence in 2022, and we published another paper just recently on this. This is a preprint that you see. We received word only recently that this has been accepted for publication now. So I think we're at a point where we can really say that an appropriately constructed nanopublication is coincident with the emerging fair digital object specifications. So if that's true, then there could be some nice implications here. What it means is we're able to create a nanopublication template that is a bona fide fair digital object, and we're borrowing some of the vocabulary from the fair digital object forum. These are the conclusions. I won't go into them in detail here, except for number 3. It's just to say that indeed, the emergence of a practical nanopublication-based FDO was quite accidental. And it was a result of a lot of really good work by independent people working on completely different projects over, 10 or 15 years. And this brings me back to this idea that being able to realize these visions and implement these things, at some level it seems impossible. At another level, it seems almost like it's inevitable. So how does this relate then to the MCBK community? If this is a knowledge graph, a model of a biomedical knowledge graph, certainly each of those subject, predicate, object combinations could be expressed as a single nanopublication. And if they're important enough, if we know that a gene causes a disease, that's an important fact, that could be a standalone publication. But certainly every triple in the graph could also be represented with another nanopublication. So the collection of nanopublications itself could represent the graph. And we could give another nanopublication that then points to this collection. And in this knowledge graph would become, in a technical way, a fair digital object and would be available for reuse. And more importantly, services could be built up around the knowledge graphs because they're following these standardized machine actionable formats. So that's it. I hope I stayed within the time boundaries. I'm happy to take questions, and I hand it over back to Chuck.
Okay, thank you, Eric. This really is thought-provoking for me as someone who's thought about for a while how to realize the vision of MCBK technically and also from policy and other social perspective. I have for you, maybe to get things started, a probably a very simple and maybe naive question. How literally should we take the word publication in the term nanopublication? You started by saying you could take elements out of a publication and publish them as separate entities with the constituents that you described. Let me introduce the concept of composability here. And if you composed all of the nanopublications that point to the same, call it macro publication, how complete of a macro publication would you have?
Yeah, sure. So certainly if we parse out the word publication, it says to be made public. So I think in the nanopublication from the beginning, there was a feeling that these things should be like public and probably should even be open, right? So they should be really available out there. The other connotation we have with publication is that, when you publish a research article, you never unpublish it. You never delete your article. You may at some point have to publish a retraction, but in a way, the retraction is yet another publication. So the nanopublication server network was designed in exactly this manner. Once you publish a nanopub, it is eternal. It is there forever. You can retract it or you can deprecate it. using yet another nano publication. And you could arrange for services that could then, filter out retractions, etc. So that's maybe the first part of your question is around the publication aspect. Regarding like the composability, maybe it's important to say there's no rigorous definition of what makes a nano publication like nano. You could, in principle, put anything in that assertion container. You could put an entire book in there. And in a way, when we began thinking about nano publications as fair digital objects, yeah, it kind of opens the door to that. Okay, the assertion can be something more than an atomic semantic unit. It could be something bigger. But what we've experimented with so far is composing larger fair digital objects out of smaller fair digital objects. So every component is also a fair digital object. Once you kind of dip beneath the FDO universe, you're sort of back where we are now, which is things are a little bit ambiguous. Maybe a smart LLM could figure it out, but there's probably going to be some error or noise. But if you commit to the FDO approach, then everything has metadata, everything has a type, everything has provenance, and therefore everything becomes much more computable. And I hope that answers maybe your questions.
Thank you. Thank you. Let's see who else might have put questions forward. Okay, Philip Scott.
Thank you. I grossly abused my privilege of sitting next to Chuck in the conference room here to get his attention more quickly. A follow-up question actually to what Chuck just asked you. I was trying to think of, turning this into a concrete example. Let's say we had a clinical guideline for a particular condition that was broken down, quite well structured into, the example I was giving yesterday was NICE are now proposing to move to a more structured way of presenting their guidance. So, for example, you would have a population, you would have indication, you would have contraindications, you would have desired outcomes. Now, at the moment, that's all being produced as a lump of narrative, which is then almost retrospectively structured. If we were to think ahead to producing it in a structured format, would I be right or wrong to envisage that perhaps each of those structured elements may in itself be a nanopub, but then how do we link them together? Does the metadata in some way indicate the relationship between this is an element of that in a kind of ontological sense, or you can't consider this piece of knowledge without considering that piece of knowledge, that there's a sort of dependency of some kind? What's the interrelationship if you're thinking about composability?
Yeah, indeed. Okay, so this is this is very helpful. Thanks. So indeed, so the short answer here is absolutely. If you have a guideline, a form that you can fill in, that the structure of that form can be captured with a collection of nano publications. And if you talk to the semantic ontology engineers out there, they would say you would have to build a conceptual model of the form. And that conceptual model will do the relations between the assertions, right, or the arguments that you're capturing. The way that is handled in the nano publication space is that indeed, you could imagine capturing each and every record of the guideline independently as a nanopub, and you would be referencing the question and the answer to that question in the nanopub itself, in the knowledge graph. And you have a choice. You could do it at the assertion level. You might embed it in the metadata. That's your modeling option. But certainly all those nano publications then would be interconnected through the use of identifiers, and you could be referencing each and every component with the unique identifier of the nano publication. So then it's a question, is it necessary to capture each and every record as a standalone nanopub? Maybe, maybe not. Maybe it's perfectly fine to capture this as in a file format. And what we can envision, however, based on the work we've done and kind of this discovery, like, hey, I think we just created nanopubs. Your file that you capture could have a single nanopublication that references it and says this file is of type, guideline, biomedical guideline. It was created on such and such a date. It was created under this auspices or under this organization. Maybe there was funding behind it. You could put the funding, so you could build a little metadata tag uniquely tied to that document. And that metadata tag lives in the nanopublication server network, and you could always retrieve it later. And so could anyone else, right? So you can kind of keep track of your assets by publishing those metadata tags into the nanopublication server network for anything, right? It would be then completely general. It could be any kind of document or code or resource that you have.
Thanks. And just to clarify one point, if I may. So you talked about having a separate conceptual model. So would that in itself be another nanopub, or would that be part of the collection?
So I think typically the conceptual models live as a kind of independent entity. They're published somewhere on a GitHub or something.
Right.
So you can still point to them. If you're familiar with Shackle documentation, Shackle is a language that describes sort of the shape of that conceptual model and will help the machine navigate, what it sees in that conceptual model.
Yeah.
So Josh Richardson posted a question in the chat. Josh, do you want to unmute and put your question forward to Erik? And then we'll take Maria, Michaels, and then Blackford.
Yeah, thanks, Chuck and Erik. Thanks for the really fascinating, fantastic presentation. As I put in the chat, mine isn't so much a question as just kind of an observation after noodling over your presentation and thinking about some of the work that Alper and others here in the MCBK community have done around FAIR plus concepts of trust. So a FAIR plus T framework. And so if you're not familiar with it, it might be something to consider, and because there's just some really interesting overlaps and maybe some synergies there to build off of what you've already done in terms of linking provenance to FAIR digital objects, but maybe even some additional considerations that Brian and others, the co-authors, did in that work.
Absolutely. I have the link open, and yeah, I would love to take a look at it. And I'm ready.
Don't mean to, not meaning to put you on the spot, but it's just wanted to share that with you in the community too. It's like, I think some opportunities maybe.
Absolutely. But maybe I just would mention, oftentimes I'll get the question like, oh, so there's FAIR, but like, what about like trust or ethics or, some kind of quality measure? And just to be clear, the thinking that went into the FAIR principles, it was actually by design excluded an explicit statement about trust. And it sort of left that to the domain communities. Because it's usually very contextual, and what's high quality or trustworthy for one application might not be for another. And so it was thought wiser to kind of exclude that explicitly, but given rich metadata, you could probably infer better whether or not this data is trustworthy for you or reusable under some conditions, under, fit to some purpose. So just to flag that we don't anticipate additional letters to FAIR from design or from intention.
Well, we use FAIR T. And I hope
Perfect.
it's considered acceptable by the Ministry of Fairness.
Perfect. Perfect.
Maria, would you unmute and put your comment to Erik?
Sure, it is just a comment, but feel free to infer a question if you'd like. I was just noticing that there's some overlap in how you were thinking about nanopublications and components of them ultimately, stacked together and creating kind of a larger machine readable publication. And that's very similar in terms of the concepts and ways that CPG on Fire, which is the Fast Healthcare Interoperability Resources specification in terms of the health IT standard that's been specified for computable guidelines, has thought about living guidelines in particular. So thinking about attaching like an ID to each component and then being able to update just that component instead of having to update the entire guideline each time and creating a new version of an entire guideline. So just making that observation and thought that was interesting.
And you have a link to this. It's called Speakeasy.
No, CPG on Fire. It's a health IT.
On Fire. Yeah, got it. Yeah.
I will put it's about to be updated too. So this link that I'm putting in the chat, you can use the same link in hopefully a couple of weeks. There should be an updated version, which would have more information about what I just spoke to. So.
Okay, great.
Okay, thank you, Maria. Okay, Blackford, you're next.
Well, thank you, Erik. That was a terrific talk, and I've learned quite a bit about nano publications from you. So thank you. It's very interesting to me because it seems to actually sort of follow the composite nature of knowledge objects that I've always kind of intrinsically or intuitively thought we need to go in that direction. My concern is, though, when you construct the knowledge graph and you're actually looking at a large graph, lots and lots of triples, how do you, it's hard enough just to ensure consistency and coherence across the graph in that form. How do you ensure coherence and validity when it's all nano publications? Could nano publications result in semantic variance or other kinds of complications when they're viewed individually?
Nice risk identification here. I think we've always kind of assumed, maybe rightly or wrongly, that the careful work that you might do in constructing an individual nanopub, so choosing the vocabulary systems wisely, structuring the properties well, that your choice at that level should be made in an informed way with respect to how widely the resources that you're using are used by others, and what kind of mappings might be available to other common systems, such that when you publish your nano publication, there is already some fighting chance that the ambiguities could be resolved or mappings could be established, and that nano publication or the information in that nanopub could be machine translated in a very accurate way into another vocabulary system. I think that's the assumption we're operating on. How that may work in practice, for very large collections of very diverse data is another thing we have to investigate, I think.
Chuck, quick follow-up. Just, Erik, I wonder if this then implies the need for sort of a authoring environment which can provide guardrails to the end user who may not know all the vagaries of terminologies and ontologies, but needs to pick from a secure set or a validated set of component objects to create these nanopubs.
Blackford, it sounds like you're advocating for an MCBK portal environment where people can author nanopublications with the assistance of vocabularies and in properties that might be standards agreed upon in the MCBK community. So
along those lines, Erik and Blackford, I've been sitting here thinking about whether you have pointed us toward a next generation MCBK. by thinking about our digital objects that we have been largely conceptualizing at a higher level of scale and thinking about them instead as composable entities at a smaller level of scale. And then I'm saying to myself, wait a minute, we haven't even conquered the current generation of MCBK. Should we be thinking about the next? And of course, the answer to that is yes, we always should be looking ahead. So to kind of bring this part of this session to an end, in addition to thanking you for opening our eyes, I think you pointed the MCBK community, a representative sample of which is with us today, toward a future which I think we need to start considering now.